Okay, here we go. Here's the tutorial for the Unit 5 drawing project. Throughout this video, I put in slides in between that says what section of the project that we're on. So feel free at any time to fast forward or pause during certain sections of the video. If you feel like you already know how to do a piece, then just like fast forward to the next section for that part of the tutorial. To get started, we do have to have a graph. I assume most people, including myself, just have lined paper at home. So we do need to make a graph on our lined paper. First thing that you're going to want to do is fold your paper in half. That's going to make our x-axis. And then you will fold the other side of the paper vertically. That's going to be your y-axis. So open it back up. And you can use a book. I would recommend a book, something that has a straight part to it. Oh, it's my head showing there. And line it up with the crease that you just made. And you can use your pen or your pencil to go ahead and mark that axis. And just try and make it as straight as you can. Okay, and so that's the x-axis. I'm going to put in the y-axis. So, there we go. And there we go. Okay, so something that's nice about lined paper is that it is already lined up for the y-axis. We just need to make our lines for the x-axis. So you can use a different sheet of paper because they have the same width to mark your x-axis so it's all lined up. So you just need to make sure that you have a blue line going through your y-axis, and then you can start marking your points so you know that they are even. And the negative direction. Okay, there we go, and then maybe add one more. And then for your y-axis, your points would be along your blue lines of your graph. And I would recommend that the top of your graph actually be the bottom of your paper since it has lines going all the way up. And then the next part is that you would be labeling your axes. So this would be like 1, 2, 3, 4, -1, -2, -3, -4, and you would keep going in both directions. 1, 2, 3, -1, -2, -3. So you label your axes, and then I'll actually show you what my final product ends up being. So your next step after you label your axes is that you draw your figure, you draw your shape. Remember that you have to have at least one circle, you have to have at least one square or rectangle, and at least one triangle or parallelogram. I chose to do a robot, so I first started out by doing the boxed head, and then I did my circles and did the body. Okay, so stay tuned for the next part about how to label your corner points and things of that nature. Okay, so next you should mark your corner coordinate points. So like for instance, this is 4, 4. And over here, this corner is -4, 4. This is 4, -4. This is -4, -4. And you would like continue to mark your corner parts that are on the outside of your figure. Okay, so you also need to mark your corner points inside of your figure too, if you have any shapes inside of your picture, and especially for shapes that are slanted, because you're going to have to use the distance formula to find the perimeter of those figures. Okay, now to the more mathy parts. So part of this project is giving the equations for the circles that you draw in your picture in the standard form. So let's look at where the center of the left eye is. It's at -2 and +2. So that's the center of the circle. So remember, if it's coming from the parentheses, you change the sign. So it would be x plus 2 squared plus y minus 2 squared, change the sign, equals our radius squared. Well, let's look back at our picture. Looks like the radius was only 1, so 1 squared is just 1. So for the left eye, that's the standard form equation. And for the right eye, the center of this circle is 2, 2. So change the sign if it's coming from the parentheses. So x minus 2 squared plus y minus 2 squared equals, and it's the same radius, 1. 1 squared is 1. Okay, so the next part of this project is finding the perimeter. The perimeter of your drawing. So be careful with this, because for instance, I drew like a little robot, but I'm not going to count like this inside portion right here as the perimeter. The perimeter is the outside of your figure. So I'm just going to count like the pieces that are actually outside of the figure, and then I'm also going to find the perimeter of the inside shapes, because those are complete shapes, but I'm not going to count like this neck part right here because it's not on the outside of the shape, it's on the inside. Okay, let's keep going finding the perimeter of our figure. I'm going to do the head first, and I drew this as a square, so I know it's symmetric on all sides on the outside. So from the center to the edge, that's 4 units, therefore to the center to the left edge, it's 4 units. So the top will be 8 units, the left side will be 8 units, the right side will be 8 units, and then like I said, I'm not going to count this neck part because that's technically the inside of this shape. So on the bottom we have 1, 2 units, and then 1, 2 units, so that's +4, and then you add that all up. So 8 times 3 is 24, plus 4 is 28. So the perimeter of the head is 28. And I'm just going to continue to do the rest for the body, the arms, and the legs. And I'm also going to do the mouth, and then I'll do a second part of the video talking about how you find the perimeter of the nose and the perimeter for the eyes. Okay, now we need to find the perimeter of the eyes, the nose, and the mouth. So for the left eye, that's a circle. The formula for the circumference of a circle is circumference equals 2 pi r, so r being your radius. So for the left eye, it's 2 pi, and then we already said that the radius was 1. So then the left eye circumference is 2 pi. And since the circles are the same, then the right eye circumference is also 2 pi. For the rectangle, the mouth, that is 1, 2, 3, 4 units on the top and the bottom, and then 1 unit on the sides. So 1 plus 1, so 8, 9, 10 is the mouth. And then the triangle nose. So you could do one of two things. You could do the distance formula to find the distance between the point 0, 1 and negative 1, 0. Or you could use the Pythagorean theorem to find that distance right there. So I'm going to do the Pythagorean theorem just because it's a little easier. So if I'm looking at what the base of this triangle here is to find the distance between these 2 points, I see it's 1 unit on the base, so 1 squared, plus it goes up 1 for the height, and you do the square root of those. So 1 squared is 1, 1 squared is 1, so it would be, this would be equal to the square root of 2, and so the other side is also going to be the square root of 2, so plus the square root of 2, and then the base is 1, 2 units plus 2. So square root of 2 plus the square root of 2 plus 2, and you can do this on a calculator, you can do this on Desmos.com, you could use Google. If you type in numbers into the Google search bar, that also works as a calculator. So as a decimal, that's 4.83. 4.83. And those are all of my numbers for the perimeter. The last thing that I need to do is add these numbers together to get the full perimeter. So the perimeter of my robot is 28 plus 6 plus 5 plus 5 plus 12 plus 2 pi plus 2 pi plus 10 plus the nose was 4.83. That was the last thing we found using the Pythagorean theorem, or you could have used the distance formula between the 2 points. We get the perimeter as 83.3 or 83.4 rounded to the 10th place units. Okay, and that's how you would find your perimeter of your figure. Next up is area of your figure. Okay, so last thing before you start coloring is that you are finding the area of your figure. This is all the stuff that is the body, but also the shapes on the inside of your figure as well, if there are shapes on the inside of your picture. So I'm going to start with the face. That's a square, so the base and the height are the same. We found with the perimeter that it was 8, so it's 8. The head is 8 times 8, 64. And so now we're using area formulas. For a square, for a rectangle, that will be base times height. The body, that is not a square, it's a rectangle. So let's see what the base and the height are. We have 1, 2, 3, 4 as the base, and then the height is 1, 2, 3, 4, 5. So 4 times 5, 20. That's the body. Let's do the left arm and then the right arm. Left arm. So base 1, height 3, so area 3, 3 times 1 is 3, right arm will be the same, they're symmetric, I drew them that way, 3, and then the legs, base 2, height 1, 2, 3, 4, 5. 5 times 2, 10. Okay, so that's like the head, the body, the legs, the arms. Let's do our eyes, our nose, and our mouth. So for the eyes, those are circles. Let's do left eye. Left eye, the formula for the area of a circle is area equals pi r squared. So we know that the radius is 1. We did that with the perimeter. We have pi 1 squared, which 1 squared is 1. So the area of the left eye is pi. And then the right eye will also be pi because I made them symmetric circles. Maybe you have a different type of animal or robot or something that had 2 different sized eyes. I don't know. You can do whatever you want. Let's do the triangle, which is the nose. The formula for the area of a triangle is area equals 1/2 base times height. And so formulas for like triangles and circles and things like that, that's on your formula sheet. It should also be on the Weebly site available for you. So 1/2, the base of this triangle is 2 units times 2, and then the height of the triangle is 1 unit. So 2 times 1 is 2, 2 times 1/2 would just be 1. So the nose has an area of 1 unit. Then let's do the mouth. Mouth, and this is a rectangle, so it's base times height again. The base is 1, 2, 3, 4 times the height, which is 1, so 4 times 1 is 4. Last step is we add these numbers together to get the total area of your picture. So we got 64 times 20 times, oh, I'm doing times, I should be adding. So 64 plus 20 plus 3 plus 3 plus 10 plus pi plus pi plus 1 plus 4 is 111.3. The total area is 100 11.3 units squared. This is area. Okay, and then the last part of this project before you start coloring is to do the proof for either a square or one of the rectangles in your picture to prove that it really is a square or it really is a rectangle. So that's the next part of our video. Okay, last part is you need to prove that either one of your squares is a square or one of your rectangles is a rectangle. I'm going to do the head that is a square. So the things that you would need to prove is that all sides are equal, and that your adjacent angles are 90 degree. So all sides are equal, well that would just be showing that all of the sides have the same length. So we already said that at the top is 8. Top is 8 units, bottom is 1, 2, 3, 4, and then 4, 8 units. The left side is 8 units, and the right side is 8 units. So are all of the sides equal? Yes. And then we need to show that the adjacent angles are 90 degree. Well, what you'll notice about my lines is that this line has a slope of 0, and these lines are undefined and they intersect. So if this slope is 0 and this is undefined and they intersect, then that's a 90 degree. So all corners intersect with undefined and slope 0 lines. Slope 0 just means that it is flat and it is not changing. So great, like this would be positive, that would be negative. This is just flat, so the slope is 0, it's not changing. Intersect, so all corners intersect with undefined and slope 0 lines. Therefore, all corner angles equal 90 degree. And those are our two qualifications. So therefore, the head is a square. If you were proving for a rectangle, then you would need to show that opposite sides have equal length, and then you would need to show that you have adjacent angles that are 90 degree, or you could show that the diagonals are congruent as well using the distance formula, or you could also show that the lines would bisect each other. So that would be how you would do it for a rectangle. And then your last step is to color your picture.